Okay, good morning, algebra friends. So this is Mrs. Pasternak, and I am looking at the lesson that's in your packet that's dated 3/16, and it says, what goes up must come down like a parabola, and it's basically real-world parabola problems from day 2. So make sure that you have those notes so you can follow along with me. Again, this isn't the most ideal way that I'd like to teach because it would be better if I was in the classroom, but this is the best I could do as far as explaining the concept to you. You can hear my explanation. You can play it. You can fill it in yourself. You could check it. You could fast forward if you don't want to listen to it. See how it goes, okay? The stylus and the writing on here is a little harder for me, so you're going to do a much better job at graphing, but I'm going to do the best that I can, and you're just going to have to bear with me. So let's take a look at the do now. It says a football player throws a ball from the end zone toward his wide receiver. The ball's height above the ground is modeled by the equation h equals negative 16t squared plus 48t plus 6, where h represents the height in feet and t represents the time in seconds. The ball is initially thrown from a height of 6 feet. What is the maximum height that the ball reaches? Okay, so the first thing I'm going to do actually is I'm actually going to connect the dots. So it starts and it stops at 0 to 3. Because at this point, it doesn't actually hit the ground because someone actually catches it. Hopefully that makes sense. All right, so let's see. What is the maximum height that the ball reaches? So the ball reaches, and I think it is 42 feet. Let's see if we can answer these questions and move these things where they need to go. I'm going to have to draw lines just like you. So let's do that together. So the ground is at the 0, and that's nowhere over here. It never hits the ground. So the maximum height of the ball is going to be up here. The increasing interval is on the left side of the parabola. And then the initial height of the ball is over here. And then decreasing interval is on this side of the parabola where it's going down. The ball's final location is here when someone catches the ball. Okay, let's head to the next page. So example 1, a rocket is launched from the ground and travels in a path modeled by the equation h of x equals negative 16x squared plus 64x. Given the domain between 0 and 4, where h of x represents the feet above the ground and x represents the time in seconds. Okay, so let's label our axes. So the x part is labeled, and that's in seconds. The y-axis is height. And again, you're going to be better at this than I am. We need to figure out what that interval is before we start graphing this. So what I'm going to do is I'm going to turn on my graphing calculator. I'm going to plug in y equals, and I'm going to plug in negative 16x squared plus 64x, and then I'm going to hit second graph to generate a table so I can get some points to graph. So I'm looking at the x-axis right now, and it already goes up by 0.5. So I'm going to change my window. I'm going to hit second window. And I'm going to have a starting point of 0, and I'm going to have it increase by 0.5, and then I'm going to hit second graph again. And then I'm going to be able to graph some points. So I have 0, 0. I'm going to put a dot there. Again, your graph's going to be a lot better than mine. So it goes from 0, 0. So I'm looking at it goes 28, 48, 60, 64, 60. So the highest number I need to go to is to 64. So I think what I'm going to do is I'm going to go up by tens. So I don't think I'm going to be labeling each of these. I'm going to do 20, 40, 60, 80. Okay, so at 0, 0, 0.5, 28. So that's like there, basically. 148, so somewhere around there. 264, nope, 1.5, 60, 264. And that looks like the vertex to me. It's a little bit, nope, that's too high. Oh no, technical difficulties here. Okay, 64 is going to be like here, a little lower. Then we have 2.5, 60, 348. Again, I'm doing my best here, I apologize. 3.5 here. By 4, it goes back and hits the ground. So I'm going to connect. And I'm going to label h of x. All right, let's see if we can answer the questions. How many seconds did it take the rocket to reach its maximum height? So the vertex happens at 2 seconds. What is the maximum height? If I look at my table, because my graph is not so hot, I'm going to say 64 feet. How many seconds did it take the rocket to reach the ground? We said 4 seconds. What was the rocket's initial height? So it started on the ground at 0 feet. What was the rocket's distance from the launcher when it landed? So I don't know. Don't know distance. So the horizontal axes over here, this is representing time. That's not distance. So I don't know the distance, how far it is from the launcher. I just know how much time it took. So I can't actually answer that question. All right, let's try the next page. Example 2. A ball is thrown upwards from the ground level at a speed of 48 feet per second. Gravity pulls it down at 16 t squared after t seconds, and the path of the ball follows the equation d of t equals 48t minus 16t squared over the interval from 0 to 3. Okay, so that's a little weird looking because we don't normally have things that are not in standard form, but I'm going to plug it in exactly the way that I see it. So I'm going to go to my y equals. I'm going to clear out whatever's there. And I'm going to plug in 48, and there's no t on my calculator, so I'm going to use x minus 16x squared. And then I'm going to generate a table. And my table is still going up by 0.5, so I actually am happy about that because I can see the vertex really nicely, and it does make it a little bit easier for me to graph. So I'm actually going to leave with the 0.5s. And I am going to label my axes. So this is basically time. Hold on. This is time, which is actually in seconds. The horizontal axis is height, which is in feet. All right, so let's think about how high I need to go. So the seconds are going to go from 0 to 3. I'm going to count by 0.5s though. So 0.5, 1, 1.5, 2, 2.5, 3. So I'm going to go 0. For my height, the highest point I need to get to is 36. So I think I'm going to number by 5s. Again, you could number by whatever you want to. So 5, 10, 15. I'm going to number every other because I don't have a lot of space here. I have a very thick stylus. So 5, 10, 15, 20, 25, 30, 35. All right, so let's do some graphing. So 0, 0, 0.5, 20. So that's going to be there. Again, your graph's going to be much better than mine. 132, so it's a little bit below that. 1.5, 36. So we got to go right up here. Oh, a little bit lower. 2, 32. 2.5, 20. 3, 0. So we're going to connect. We're going to call this d of t. And we're going to answer the questions. After how many seconds does it take for the ball to reach its maximum height? So that's 1.5 seconds. What is the maximum height? So if I'm looking on the calculator, the vertex is 1.5 comma 36, so it's 36 feet. Don't forget to make units on here. How long after it is thrown does it take for the ball to return to the ground level? So it goes up and then it comes down and it hits the ground here. So this is my ground right here. Oh, I'm trying to get it here. The ground is right over here. So that's going to be 3 seconds. All right, let's try the next question. Example 3. Greg is in a car at the top of a roller coaster ride. The distance d of the car from the ground as the car descends is determined by the equation d equals 64 minus 16t squared, where t is the number of seconds it takes the car to travel d distance on the ride. How many seconds will it take Greg to reach the ground? Okay, the most awesome part about this is that it's already labeled for me with the intervals. I do need to label my axes. So this horizontal axis is going to be seconds, or just time. And this is distance. Okay, so let's see what we have here. Let's plug it in our calculator. Let's go to y equals, clear out anything that you have there, and plug in 64 minus 16x squared. And hit second graph so you can get a table and you can get a sense of what you're doing here. And okay, I still have my 0.5s on from before, and I actually am happy about that because it gives me a lot of points. And this graph is really nicely spread out, so I'm actually going to leave the 0.5s in there. So at 0, I should put a dot at 64. And again, your graph is going to be better than mine because you can graph better than me. At 0.5, which is sort of halfway in between here, 1, 2, 3, 4, 5. So 1, 2, and a little bit is 6D. Which is like in between here. Then at 1 and 1, it's 48. 1.5, it's 28. And then at 2, it was at 0, already hit the ground. So we're going to go like this. And we're going to call this d of t. How many seconds will it take Greg to reach the ground? So the answer is 2 seconds. All right, let's try the next one. Example 4. A ball is being launched in the air upward at 48 feet per second for a platform that is 100 feet high according to the equation h equals negative 16x squared plus 48x plus 100. How long does it take for the ball to reach its maximum height? Okay, so let's plug this in our calculator. So we're going to do y equals, we're going to again clear out anything that's in here. This one's already in standard form, so we're going to plug it in. Negative 16x squared plus 48x plus 100. And I'm going to generate a table. And I'm going to look to figure out where I need to go. So actually, I'm still on my 0.5s, and I still actually do like that because I feel like it's gives me more data to graph, which I'm happy about. I am recognizing the fact that these axes are not labeled, which makes me very sad because it's really hard for me to do this, but I'm going to do my best. So the x-axis is going to be time, which is measured in seconds. And the y-axis is going to be height, which is measured in feet. Okay, so let's figure this out. So 0's in the bottom left corner. And now I need to figure out which numbers I need to worry myself with. So basically it goes from 0 to somewhere, probably 0 to 5. Because by 5, it hits a negative number, and that means it's definitely hit the ground. So I got to go from 0 to 5. I'm probably going to spread this out. So I'm going to try and do every other. So like 1, 2, 3, 4, 5. Again, you could probably do that better than me. Let's take a look at the numbers for the y-axis. So 0 starts at 0, 100. And I'm looking at this, and it goes as high as 136. So 136, so I'm probably going to need to get to 140. So I think that I'm going to do 20s, but I'm going to skip like every other. And again, my stylus is really thick, so you're going to have a much better graph than me. 40, 60, 80, 100, 120, 140. I really hope I did that right. All right, so let's start. It's 0, 100. I'm going to change colors here. Let's do green. So 0, 100 is here. Then I have 0.5, 120. So I'm going to go up a little bit more, which is helpful. Then I have 1, 132. Again, you have to use your best estimate here. So it's like there. 1.5, 136. So again, it's under. 2, 132. 2.5 goes here. 3, 100. 3.5, 72. 4, 36. And somewhere between 4 and 4.5, it's going to hit 0. So I'm going to connect this. This graph is pretty horrific. I hope yours is a lot better than mine is. And I'm going to label this h of x. Okay. It says, how long does it take for the ball to reach its maximum height? So I can actually get that from my table, and I'm going to say 1.5 seconds. What is the maximum height? I'm going to look, and it's 136 feet. To the nearest tenth, that's important, of a second, how long will it take for the ball to hit the ground? So clearly we don't know exactly where it's going to hit. So we're going to use the quadratic formula. So I'm going to make a suggestion to you. So I'm looking at this equation, negative 16x squared plus 48 plus 100. That's some really large values for A, B, and C. So I'm actually recognize the fact that there is a GCF. So I'm actually going to rip out the GCF of negative 4. And that's going to leave me with 4x squared minus 12x minus 25. And those numbers are going to be a little bit easier to do. So A is 4, B is negative 12, and C is negative 25. And I'm going to substitute those in the quadratic formula. And I got x equals, and I'm going to do the opposite of negative 12, plus or minus the square root of negative 12 squared minus 4 times negative 25, and all over 2 times 4. And I'm going to simplify that, and I'm going to get 12 plus or minus. And under the radical, I am getting the square root of 544. And that's all over 8. So the square root of 544, excuse me, you can plug that in your calculator. So y equals 544 over x. And then under y2, you can plug in y equals x squared. So you can look for the perfect squares that go into it. And I happen to recognize that the square root of 16 and the square root of 34. 16 is the perfect square. So I'm going to rewrite this. I'm going to move up top here because I actually ran out of space. And I have x equals, and I'm going to have 12 plus or minus, and then I'm going to write 4, because that's the square root of 16, rad 34, all over 8. So I can still simplify this because the 12, the 4, and the 8 all have a common factor of 4. So I'm going to write 3 plus or minus. 4 goes in here once, which I'm not going to write. Square root of 34, and I'm going to put a 2. All right, so let's talk about how to punch this in our calculator correctly. I did talk about this on Friday before we left, but not many of you are going to remember. So I want you to hit the second mode and get a clean screen, like the basic screen. And we're only going to plug in the numerator, and I must plug it in parentheses. That's key. So I'm going to hit the left parentheses. I'm going to plug in 3 plus, that's all I'm going to do, second x squared to get the square root key. And I'm going to plug in 34, and then I'm going to right arrow out of that so that it's no longer under the radical, and I'm going to hit the right parentheses. So right now in my parentheses, I have 3 plus the square root of 34, and all surrounded by parentheses. That's the numerator, one of the roots, and I'm going to divide it by 2. And then I'm going to hit enter. And it says to the nearest tens place. So I'm going to have 2 answers here. So I'm going to do the plus one first. And it says 4.415475947 on your screen. If I round to the nearest tens place, I get 4.4. I'm going to do the next one, which was the minus. So in order to do it faster, I'm going to hit second enter on my screen. And it just recopies whatever you just typed in. And I'm going to left arrow until the black cursor is hovering over the plus sign, and I'm going to make it a minus. I'm going to type right over it. And now it says in parentheses 3 minus the square root of 34, close parentheses, divided by 2. And I'm going to hit enter. And to the nearest tens place, I get negative 1.4 rounded. So I'm going to reject this because I cannot have negative time. And it says nearest tenth of a second, how long will it take for the ball to hit the ground? So I have 4.4, which if you look at the graph, it actually makes a lot of sense because it sees that it's hitting the ground a little bit after 4, but not at 5, and a little bit before 4.5. So I think that's pretty good. So I'm just going to label this. I don't really have space here, but I'm going to write it anyway. 4.4 seconds. All right. Let's try the next slide. Oops. Sum it up. Awesome. All right. Parabolic paths in the real world take place in which quadrants? So which quadrant do you think they are? I think quadrant 1, because if it's real world, we need positive things like positive time, positive feet, positive distance. The initial height of the projectile is always the y-intercept. The maximum height of the projectile exists at the vertex. The height itself is actually the y value of the vertex. The blank root of a quadratic equation represents the horizontal change, the time it took to land on the ground, the distance away from the feet. And I'm going to go positive root. Do you see how in the last example, when we got a negative root, we rejected it? And that's it. So I'm going to post a blank of the homework. I'm hoping that you could do it. And I will post answers to the homework for you the following day for you to check. And then I will have sometime next week where I'll have Google Meets where we can sort of all join up digitally, and I can answer questions that you have. So hopefully this lesson wasn't so bad for you, and I'm going to try and use this for you to get the notes. So you're going to have to make sure you have your packet, make sure you have your graphing calculator. each time that you're going to look at one of these videos, and then you'll be able to follow along. Okay, thanks. Bye, guys.